Es que cuando llegue ese tornillito, hay que sobrevender. No, que uno, ahí hay tres, que es uno nada más. ¿Por qué? Mira que ahorita vamos para allá atrás. Vamos allá atrás que allá no coge. Ya lo que para no para allá atrás.
Okay, buenos días, good morning. Good morning to everyone. Thank you for being here. Okay, this doesn't gonna take too much time. Okay, ¿me escuchan todos? Okay, perfecto. Voy a pasar lista rápido para ver quién está. Okay, esta es una reunión extra. Pero Juan Diego está ahí, Nayara Santiago, Arena, Basora, a ver quién más. Jeremías, Diego también está ahí. Diego Rodríguez, Sebastián, Narelis Valentín está ahí. Vamos a ver quién más. Gabriela Ortiz, dime. Ok, ¿quién es? Ok, perfecto, gracias. Ana está ahí, Ana Cortés. Vamos a ver quién más. Adrián está ahí. Génesis Nieves Soto. Ok, esos son los que. Ok. Gabriela, a ver si Gabriela la puse. Y Gabriela, ok, perfecto. Pues nada, buen día a todos. Okay. Vamos a comenzar, ¿verdad? Let's finish section 1.6. Okay. Ahí no habíamos quedado. Okay. So we can start saying that the ruler postulate can be used to find the distance between 2 points on a number line. Okay. So we're gonna introduce a new formula that we're gonna use. Okay. This is the distance formula. Okay. So the distance between 2 points. This is the formula we're gonna use. Okay. We got points x1, y1, and x2, y2. So we have the coordinates. So what we have to do? We have to put everything where it goes, okay? Inside the formula, okay? So let's continue. Gente, hoy la clase es corta, okay? No se preocupen. Que hay que me preguntó en el chat. Nos reunimos, Diego, para terminar lo que nos faltaba, okay? Okay, so let's do example 3. It says find fj and jk, then determine whether segment fj is congruent to jk, okay? So we got the coordinates, okay? So the next step we have to do is substitute that in our formula, okay? In our distance formula, okay? So we got the coordinates. We know that these are the coordinates. For example, okay? So we're gonna use fj and then jk, okay? So we're gonna use these coordinates to do the problem, okay? So it's gonna be like this, okay? So we're gonna use the distance formula, okay? The distance formula is this: the root square of x2 minus x1 square plus y2 minus y1 square, okay? So we're gonna put everything there, okay? We're gonna start with fj first, okay? x2 minus x1 plus y2 minus y1 all to the square. So 5 minus 1 is 4. So 4 to the square, okay? Let me do it so you can see it. It's gonna be something like this, okay? So we continue using the formula, okay? The last thing we're gonna do is work with the root square. So 5 minus 1 is 4, okay? So after this, we have to use the square, okay? It's gonna be 4 to the square, or 4 squared. And 5 minus 2 is gonna be 3, okay? So who can tell me what's the answer in those squares? ¿Cuánto nos darían? ¿Quién sabe? Okay, so 4 squared, or 4 to the power of 2, is 16 because it's 4 times 4. Okay, and 3 to the power of 2, or 3 squared, is going to be 9. Okay, so we're going to add that, and we're going to have that the answer is 25. Okay, so then we go to the calculator, and we can evaluate this. Okay, and the root square of 25 is 5. Okay, okay, sí, ya hemos chequeado quién llegó. Vaya, no se preocupen. Okay, so let's find the other part. Okay, preguntas de cómo se hace esta parte. Okay, so after we do this, we have to evaluate the other coordinates. Okay, tenga eso tome nota de eso rapidito para seguir con el próximo. Okay, we're gonna do some examples today, and that's all we're gonna do. Okay, and then assign the material for this lesson that we have left. Okay. Lo tiene, mi gente. Can I continue? Recuerden, esta presentación está en el LMS. Estamos discutiendo, ¿verdad?, lo que faltaba, ¿ok? Okay, so let's continue. Okay, so now the answer is 5. So let's do the other side, okay? We also have the coordinates of JK, okay? Let's do this quick so we can see what happens if they are congruent or they are not. Let me do it, okay? So we got the other part, okay? -1 minus 4 or minus -4, this is gonna happen, okay? The negative or the subtraction gonna turn to a positive or a addition sign, so it's gonna be 3, okay? Se supone que sepamos esas reglas, okay? So it's gonna be 3. And on the other side, -3 minus 0 is 3, okay? It's gonna be -3, okay? So if we use the squares in these problems, this is gonna give us, ¿qué nos da esto? ¿Quién me dice rapidito? 3 to the square and -3 square. Okay? What's the answer in both of those problems or squares? 9. Okay, so it's gonna be 9 plus 9. Okay, and if we put this on our calculator, okay, 9 plus 9 is 18. But when we evaluate the root square of 18, we don't have an exact number that give us 18. So it's gonna be something, if you put that on your calculator, it's gonna be 4.24. So what happens? Does the answer are the same? Does fj is congruent to jk? Can someone tell me? The value, the distance is the same, yes or no? La distancia es la misma. Exacto, pues así que no son congruentes, ¿verdad? That's what we are trying to do, okay? So when we use the distance formula, we determine that fj is not equal to jk, okay? So that's basically what you have to do in those kind of problems, okay? Any questions about this problem? Preguntas de esto. ¿Estamos? Es solo sustituir y, ¿verdad? Trabajar con la fórmula, okay? Okay, let's continue. We're gonna do something more, okay? Okay, let's do one more. Okay, find EF and JH, then determine if the segment EF is congruent to JH. Okay, so we're gonna use EF and JH. Okay, vamos a verlo. Okay, so we're gonna find the coordinates of EF and JH. Remember, I don't know if you remember from the last lesson, but EF, this is x1, this is y2. Okay, you have to remember that. Okay, and this is x2, and this is, okay, you have to remember that because we saw that, okay, when we start this lesson. Okay, or sorry, this is x1 and y1. I'm sorry, I did it the other way. Okay, this is x1 and y, estamos en vivo. Okay? X1 and y1, x2 and y2. Okay, so after we do that, we have to evaluate. Okay, so let's put everything inside the distance formula. Okay, let's see it fast. Okay. So now we're gonna do the same thing. Okay, we're gonna use the distance formula. Okay, it's the same formula. Okay, we're gonna evaluate EF first. So let me do it. It's gonna be something like this. Let's do it fast. Si tiene pregunta, me avisa, estudiante. Okay. So we're gonna evaluate, ¿verdad? -5. What happens to the subtractions? Turn to positive, or it turns to addition. So -5 plus 2 is gonna be -3, and we also got the square. Remember that. And -5 minus 1 is 4, and we also got the square. Okay, we're always going to evaluate by the square. Okay, so what's going to be the answer? Okay, it's going to be -9, and 4 to the square is the same as 4 times 4. That's going to be 16. Okay, ¿quién me dice cuánto es 16 plus 9? 16 más 9. 25, mi gente. Okay? And when we evaluate this, the final answer is going to be, so the distance is, ¿cuál es la distancia entonces, mi gente? Hello. Cuando usted evalúa la raíz, ¿cuánto? No, para la raíz cuadrada de 25, ¿cuál es? La vimos ahorita, 5. ¿Okay? Porque 5 por 5 es 25. ¿Okay? Usted hace eso en su calculadora. ¿Okay? Se supone que eso lo haya visto en álgebra. ¿Okay? So let's go to the other coordinates, ¿okay? To see if they are similar or equal. Vamos a verlos rápido. Entonces, ¿verdad? Eso daría 5. So let's do the other one. Okay? In the other one, we got 3 minus -1 to the power of 2, and plus 1 minus -2 to the power of 2. Okay? So we're going to do it. It's going to be, it's going to give us 2. It's going to give us 4, sorry. Because when we change the subtraction to addition, it's going to be positive. So it's going to be 4 again. 4 to the power of 2. And in this part, we're going to change that to addition. And the signs change. So it's going to be, ¿quién me dice qué nota rápido de este ejercicio? What do you notice very quick? That the distance is going to be? What do you notice? Can someone tell me? va a ser lo mismo. So we can see very quick that the distance in these two coordinates are equal. Okay, so these segments are congruent. They have the same distance. Okay. Any questions, students? ¿Estamos? ¿Preguntas? ¿Dudas? So both distance are 5 when we evaluate, ¿verdad? The root square. Okay. ¿Dudas, preguntas, estudiantes? ¿Estamos? So basically, this is how we apply the distance formula to find the distance in coordinates, okay, in different coordinates, okay. ¿Estamos? ¿Preguntas, dudas? Okay. Okay, let's continue. We are almost there, okay. Estamos terminando. Es corta, le dije. Okay. So let's continue if there are no questions. Okay, vamos a continuar. Okay, so it's gonna be 5, okay. So EF is equal or congruent to JH, okay. Eso es bien importante. Eso es lo que póngale mute, escucho algo por ahí, okay? So let's see the other problem, okay? This is example 4 on your textbook, okay? You can also use the Pythagorean theorem to find the distance between 2 points in a coordinate plane, okay? We will learn more about this in chapter 5, okay? But let's see, okay? In a right triangle, okay? You have to remember what is a right triangle. The two sides that form the right angle are the legs, okay? So the side across the right angle that stretches from one leg to the other is the hypotenuse, okay? In the diagram, A and B are the lengths of the shorter sides, okay? We're gonna see this in a diagram of the right angle. So the longest side is what we call the hypotenuse and has length C, okay? Okay, so basically this is what we're talking about. We got sides A and B that are the legs of the right triangle. They are the shorter sides. ¿Cuál usted ve que es el lado más largo del triángulo recto? What's the longest side ¿verdad? ¿Cuál es el lado más largo o el lado que usted ve que es más grande del right triangle? A, B or C? ¿Qué usted ve? C, okay? So in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length. So the Pythagorean theorem says that h squared plus b squared is equal to c squared, okay? So we're gonna use this Pythagorean theorem to find the distance in these following problems, okay? For example, we have this right triangle. We got to use the distance formula and the Pythagorean theorem. Vamos a usar las dos fórmulas, gente. The distance formula that we see some minutes ago, and we're also going to use this theorem to find the distance to the nearest 10, okay? So let's try to do this one then, okay? Okay, so we're going to use the distance formula como vimos ahorita, okay? So we're going to start with DE, okay? So this is going to look something like this, okay? So it's going to be -2 minus 3 squared plus -5 minus 4, okay? So let's do this very quick. Gente, esto es lo mismo básicamente, okay? Hay dos formas de hacer estos ejercicios. You can use the distance formula, like we're going to see now, or you can use the Pythagorean theorem, okay? So let's try to do this, okay? So -2 minus 3, both are negative, so it's going to be -5 squared, okay? And in the other part, we got -5 minus 4. That's also going to be negative and negative. It's the same, so it's going to be -9 squared. So what do you think is going to be the answer here? Okay, -5 squared plus -9 squared. ¿Cuánto nos va a dar eso? Okay, -5 squared is going to be 25. And 9 squared is going to be, ¿cuánto sería -9 al cuadrado? Rápido, ¿quién me dice? It's going to be 81. Okay. So we're going to add this number. So 25 plus 81 is going to be 106. Okay. So when we apply the root square, okay, you can do that on your calculator. Okay. The root square of 106 is going to be 10.3, okay? So we have it, okay? It's gonna be 10.3, okay? Pregunta. That's how we do it. That's the same thing we saw a couple of minutes ago. We just substitute every value in the distance formula, okay? Any questions about this? Okay, but also students, we can also do this problem by the Pythagorean theorem, okay? So let's see something, let's see how many units I move, okay? So I move from A to C, let's count the units. I move 1, 2, 3, 4, 5, okay? And I move from C to this side, okay? I move 1, 2, 3, 4, 5, 6, 7, 8, 9. So have this on your memory. Okay, have this on your head. Okay, we move 1, 2, 3, 4, 5, and we move 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so have those numbers on your mind. Okay, we're gonna use them in to apply the Pythagorean theorem. Okay, so it's gonna be something like this. Let's see it fast. Okay, 25 plus 81 is 106. That's equal to 10.3. Okay, so let's use the Pythagorean theorem. Okay, we're gonna count the units. So we see that the A side has 5 and the B side has 9. Okay, how do you do that? Okay, I'm gonna show it again. Okay, how do you know how many units they are? So you have to move from this point. Okay, it's gonna be 1, 2, 3, 4, 5. That's where you obtain that A is equal to 5. And how do you see B? Well, you have to move from here 1, 2, 3, 4, 5, 6, 7, 8, 9. So we got 9 units in B and 5 units in A. Do you see it? So now that we know that, we can use the formula then. Okay, so let's see it. It's gonna be C squared is equal to 8 squared plus B squared is gonna be 5 squared plus 9 squared. Do you see we're gonna have the same answer? Okay, so 25 plus 81 again is gonna be 106. So how do we disappear the C square? Let's see it. To disappear the C square, we're gonna evaluate this by the root square. Okay? So at the end it's gonna be 10.3 also. Okay? Preguntas de cómo se hace esto. Estamos, so we got the same distance. ¿Okay? Duda. Vieron que se puede hacer también de esta forma, ¿verdad? En este tipo de ejercicio, ¿ok? You have to read the instructions, ¿ok? Preguntas, dudas, mi gente. ¿Estamos? Okay, so this is the other example I want to illustrate today. Okay, let's see if there's one more. So we can assign the thing that you have to do today for today. Okay, so it's gonna be 10.3 also. Okay. Let's do this one and we are done for today. Okay. Use the distance formula and the Pythagorean theorem. Okay, so we got squares. So we got the coordinates of R are 3 and 2, and S is -3 and -1. Okay, so we're gonna start using the distance formula. Remember this, students. Tienen que recordar esto. Lo he dicho varias veces. This is x1. This is y1. So this is gonna be x2 and y2. Okay. So after we know that, we can put that or substitute that in our distance formula. Let's see how do we do it again. Okay. So this is what we have. So we got -3 minus 3 to the square plus -1 minus 2 to the square. Let's see this very quick so we can assign what we're going to do today. Okay, so we got -3 minus 3 is the same as -3 minus -3. So, or plus -3 is going to be -9 squared. So in the other side, we got -1 minus 2 is the same as saying -1 plus -2 is also going to be 3. Okay, it's going to be 3 in this case. Okay? So if we evaluate these squares, the first one is -9 to the square is the same as saying -9 times -9. That's going to be, students, 81. Okay, and -3, sorry, negative 3 to the square is going to be 9. So we're going to add this together, and we're going to have that 81 plus 9 is, ¿quién me dice? Están callados. 81 plus 9 is, exacto. So when we apply the root square, we're going to have something like this. Okay? It's going to be 9.5. Okay? Okay, so we got the first part. We're going to do the same now, but with the Pythagorean theorem. Okay, so let's see it. How do we do it? We got to have the same result. Okay, we're supposed to do it and obtain the same thing. Okay, okay, I did something wrong. I'm so sorry. I multiplied 3 times 3. I don't know why. So it's going to be 6. I'm so sorry. Okay, mala mía por eso. I'm going so fast. Okay, esto nos da, I'm sorry, again, estamos en vivo, esto nos da 6. Yo no sé por qué puse 9, ¿ok? So, negativo 6 a la 2 is going to be 36, plus negative 3 to the square is going to be 9. So, 36 plus 9 is going to be 45, sorry, okay? So, this is going to be something like 6.7, okay? I'm sorry. Hice ese error. Bien, no sé por qué, no sé qué me pasó, okay? I'm sorry. So, when we apply the Pythagorean theorem, okay, how do you know how many units do I move? Okay, I'm gonna show that again so you can see it again. Okay, A has 6 units. How that happens? ¿Cómo eso ocurre? Vamos a verlo. Okay, let's do it. It's gonna be 1, 2, 3, 4, 5, 6. So we got 6 units from A. Okay, and B got 1, 2, 3. Okay, that's where you obtain those units. We got to count the units for size A and B. That's how we count the units. Okay, así es que contamos las unidades. So we can see that we're gonna obtain the same result. Okay, we got C squared equals to A squared plus B squared. We're gonna have 6 squared plus 3 squared. That's gonna be also, that we saw on the distance formula, it's gonna be 36 plus 9. Okay, so when we add that, that's gonna be 45. Okay, so when we apply the root square, we're gonna have that the answer, well, when you find the root square of 45, you're gonna have that the answer is 6. You can use your calculator. The answer is gonna be 6.7. So the distance is 6.7. Okay. Any questions? Okay. This is basically what I want to show you in this quick class. Okay. Vamos a ver si falta algo. Okay. Yo estoy grabando este video para ver si puedo ponerlo en YouTube para que lo pueda ver. Okay. Voy a tratar de grabar las clases de ahora en adelante. Okay. So the answer is 45. Okay. So we are basically done for this. Okay. Now I'm going to tell you, students, what are we going to do for today work. Okay. Por si acaso, en el LMS está el weekly planner de esta semana, ¿ok? Y ahorita voy a subirlo a WhatsApp para que los padres lo tengan, ¿ok? Fue que se me olvidó por la mañana, ¿ok? ¿Ok? This is what we're going to do. Voy a compartir la pizarra blanca. ¿Ok? This is what we're going to do, students, ¿ok? We're going to work on our textbook on problems. ¿Ok? Voy a decirles rapidito qué es lo que va a hacer. ¿Ok? We're going to work today. Problems are the following, ¿ok? This is the daily work for today. Daily, dime. Sí, también, pero desde ahora se lo puede llevar, ¿ok? Daily work for lesson 1.6. Esto es lo que nos queda a la lección 1.6, ¿ok? Y hoy estamos a September 9, 28, 2020, ¿ok? These are the problems that we're gonna practice today, ¿ok? They are on page 47, ¿ok? Page 47. Están dibujando page 47. And we're gonna try from page 47, problems 8 through 10. Okay. Let me see what other things we're gonna do. And on page, and page 48. We're going to try problems 18 to 20, okay? So this is basically what we're going to do. No son tantos problemas, okay? Solo son 6 problemas básicamente. ¿Alguna pregunta de lo que vamos a hacer, mis estudiantes? Okay? We're going to use these formulas that we saw today, okay? The distance formula, and we also can use the Pythagorean Theorem, okay? Any question? Dime. No, recuerde, los daily work de la semana tienen hasta el viernes, recuerde, siempre así, ¿ok? Si usted quiere entregarlo hoy, podría, pero debería, ¿verdad? Si lo entrega todo el viernes, mejor, ¿ok? So, dame ver, si llegaron un par de gente. Copiaron eso, mi gente, aunque voy a ponerlo en el LMS, pero tiene que tenerlo, ¿ok? ¿Lo tiene? ¿Sí? Ok, entonces, lo que me queda por hacer hoy, dame terminar de compartir la pantalla, ¿ok? Lo que me queda por hoy es lo siguiente. Voy a chequear quién llegó. Llegó Steven, rápido. Steven está ahí. Yo lo vi ahorita, no sé. Leira llegó, ¿verdad? Leira me dijo que estaba por ahí ahorita. Steven está ahí. Pero Leira está. Astrid llegó. Astrid. Ok. Leira, no sé, yo la vi, pero no sé. Diego Ramos, ¿está por ahí? Rapidito, miente. Ana Hernández, ¿está? Ana Hernández. Ok. Alanis Mercado. Ok. Dame ver quién más faltaba. Dame un breakcito. Ok, Alanis está. José Crespo, Joe, ¿está ahí? Yo, esta semana bloque B. Bloque B. Sí, exacto. Fue que yo decidí dar clase hoy. Y como quiera, mañana tenemos clase, ¿ok? Eso se puede hacer. Los maestros pueden dar clase otro día que no sea su bloque. ¿Okay? Joel Medina. Pero eso no va a pasar siempre. Eso es por hoy, ¿ok? Joel Medina está ahí, ¿verdad? Valeria está ahí. Valeria Pagan. Ok. Gustavo Alfaro, ¿está? Ok. Julián está ahí. Gustavo Cabán está ahí. Desenia la veo ahí. Adrián está ahí. Okay. Solo falta Leira. ¿Leira llegó o nunca llegó? Es que la vi, pero no sé si se tuvo que ir. Yo la vi. Yo creo que la vi. Okay. Gente, faltan personas que no me han enviado el Daily Word de la semana pasada. Ya eso está tarde. Ok, perfecto, gracias. Falta gente que no me envió. Dime. Pues me lo hubiera escrito, pero le voy a dar hasta hoy, porque tan tarde, ¿verdad? Era hasta el viernes, ¿ok? La mayoría me lo envió, pero hay unos cuantos, hay como 1, 2, 3, 4, 5, como 7 estudiantes, 8 que no me lo han enviado, ¿ok? De 9 a 2 estoy hablando, ¿ok? Pues nada, estudiante, que tenga excelente día. Esta clase va a estar grabada. Espero que haya quedado bien la grabación, ¿ok? Así que cualquier cosa, me avisan luego, ¿ok? Buen día. ¿Estamos?